We've been studying percentages in our problem-solving module, so I wanted to give you a couple examples of how percentages can be misused or miscalculated, and why it's so important for you to know how to precisely make the calculations so that you can challenge things that you're being told to make sure that it's legitimate. This first one I've taken out of your book. It deals with drugs. I'm not in any way condoning the use of illegal substances, but I thought it was an interesting example. So President Nixon in the 70s claimed that 80% of marijuana smokers would go on to use hard drugs. That means 80 out of every 100 people who smoked marijuana, used marijuana, would eventually go on to use a harder drug. The reality, though, was that 80% of those people who were already using hard drugs had first started with marijuana. That's not the same thing. That's using a different reference point. The one is saying out of everybody who smokes marijuana or uses marijuana, the other one's saying out of everybody who is using hard drugs. Okay? So if what they're saying is, so 80%, this is the truth, 80% of hard drug users smoked marijuana. So out of all of my hard drug users, 80 out of every 100 of those first use marijuana. That's what the 80% is. Okay, it's not out of all marijuana users. In fact, it says here, only 1 in every 2,400 marijuana users go on to harder drugs. So what would that percentage look like? Well, that would be go on to use hard drugs, 1 out of 2,400. That's 0.042%. Far cry from 80%, right? So how you calculate the statistics matters. Now, if you're having a hard time like wrapping your head around this, maybe this is something that'll be more related to your life, okay? 95% of college students first graduated from high school. Now, I made that number up, and I knew it wouldn't be 100 because some people take a GED test or get into college some other way. But let's suppose 95% of students on the college campus first went to high school and graduated. That is not the same thing as saying that 95% of high school students will go on to college, right? So the pool, the difference is what that denominator is. So that's very important when you're looking at statistics and percentages that are given to you. All right, here's another way that somebody can misuse statistics. $12,000 in a risky investment recommended by a financial advisor. First year, it decreases by 60%. It's risky, right? Volatile. Second year, though, wow, it increases 70%. And your advisor's like, well, that's a 10% increase overall, right? That's amazing. Is that advisor telling you the truth? Is that an accurate statement? All right, so let's break it down. We're going to take our $12,000, and it said first we are going to, what was it? Lose 60%. So minus 60% of that, and we are going to be down to $4,800. But then the second year, we're going to take that $4,800 and increase it by 70%. Oh, that's good. 4,800 plus 70% of 4,800 equals $8,160. But we started with 12,000, so overall it's actually a loss. There's no increase here at all. My advisor doesn't know what he's talking about. All right, so what is the actual thing that's going on here? So in general, we're going to let X be our original investment. Decreasing by 60% would mean we now have 40% of that previous amount. If we increase by 70%, we now have 170. So we have the whole 100 that we started with plus another 70. So that's 170% of the previous. So let me get rid of this little thing here. Well, hang on one second. All right, there we go. So what we have is 170% of the 40% of our original. When you do the multiplication, it's actually 0.68, which would be 68% of the original, or a 32% decrease. So the point here is be careful with percentages. Make sure you understand them so you can't be taken advantage of.